bloody virus. And what we will do, we will continue our lectures for Lean Six Sigma. And before we continue, moment, let me check who is following. Do you have a cup of coffee or tea, water? What you like drinking? So let's have a look. Moment. Groups, not this one. Groups. Okay. I hope it's working. Great. Now it should be better with the voice. So, welcome everyone. It's Monday. We are starting again a new week with the Lean Six Sigma training. So, just to remind you, last Friday we finished the define phase. We managed to describe and discuss all the steps are required in the define phase, and at the end we have made a project charter with the project scope, team, timeline, and before that we also managed to talk about the CTQ, critical to quality, who is allowed to say and describe and define CTQ, how to identify the customer. So we went through the SIPOC and so on, so on. So we finished the define phase, and also yes. So if you remember, this is our project book, what we are creating together during these sessions. And if anyone would like to have this project book to progress your own project, please let me know in the comments. I will share it definitely. So this is like a define phase, a project charter at the end, only what is really required. So this is the minimum. So before we will go to measure phase, as you can see, the measure phase is a blank. So before that, I just want to offer you and present a new project that came to me actually during weekend. And in general, what I offer a free Lean Sigma Green Belt training with certification for team. No, for 5 participants. Okay, so I'm looking for a team that will consist 5 participants from doesn't matter what part of the world. So this is all over the world. It's a global free Lean Six Sigma. So global and free Lean Six Sigma, full Lean Six Sigma training. And what we will do, we will we will go through all Lean Six Sigma DMAIC project, and the offer is for everyone. There are few requirements. I mean, this is free, so you will pay nothing, but it's not for free. So you will have to work, but you will pay nothing. So there's a great chance to get the knowledge, to get certificate. But there are some requirements. So first requirement is hard work. So each of you who would like to take part in this project will have to finish one project. So everyone who would like to be at this training, you will have to finish one project. And there is no escape, no project, no certification. I mean, you may be for the training, you may attend all the lectures with me. It will be, of course, online. free Lean Six Sigma Green Belt training, online training with certification. Okay, I'm just looking if my head is not covering any word. So this will be free Lean Six Sigma Green Belt online training with certification. The requirements are as follow. So the hard work you have to do during the training. Each of you will have to do one project. So of course you will I will guide you. You should not do this alone. Yes, you will be the project leader, so you will have to create a team, and the team can also be a remote team. The team should not does not have to be the team with you. It may be, but it's not necessary. You will see later on when we will discuss about the subject for the project. Actually, I think it will require a remote team as well, because this what we will do on this project will be something big. I mean, this is not only the way to give you the certificates. I mean, the certificates will be like a final award for your work, what you will do for others. So the main focus is not actually the certification. The main focus is your findings. The main focus is the results of your work. So perhaps I should not call it like free Lean Six Sigma trainings, but actually I would like to invite you for a global project, online project, when we will do 5 different separate projects. I'm looking for potential leaders for this project, and the technique we will use, it will be Lean Six Sigma. So we will use the DMAIC. So the main important is the subject for the problem, how we will solve the problem, and what will be the conclusions. We will follow the DMAIC methodology, and at the end, each of the project leader will receive the Lean Six Sigma Green Belt certification. So this is more like that, okay? So perhaps we will not call this like training. Is the Lean Six, actually it's not free. Lean Six Sigma Global Project. Okay. The name is Lean Six Sigma has impact. This was my idea. And what is the requirements? So the hard work, everyone will do one project. Okay, great. And at the end, so let's do like this. So we will follow DMAIC methodology. Okay, with my support and guidelines. So I will prepare, I will train, I will pass all necessary knowledge that will be required to fulfill this project. So, sorry, you cannot see because I'm hiding with my support and guidelines. Yes, now it's clear. Good. So you see, this is like I had an idea, I'm presenting it to you, and we are shape it together. I'm just wondering because I see. Okay, let me have a check. Okay. Good. So, what more about this project? Yes. Yeah, because I have copied this, so it will be a Lean Six Sigma global project. What is required? What is also required is internet connection with camera and agreement to use video in internet. Because with this project I want to show that almost every problem can be solved with Lean Six Sigma approach. We will also at the beginning discuss what is the best problem to solve during this project. We will collect some ideas and we will choose among, we'll discuss what is better, what is not actually good for Lean Six Sigma. The important element is that it has to be linked with process. So I will discuss it later. So we definitely, in the idea of this project is that we have to find a process that the most people are linked with, so they are doing this almost every day. One example is, for example, we prepare some food and we generate some wastes, or we, for example, segregate plastics, or we prepare something, or we clean, or I mean, the more worldwide process that has impact to environment, to our life, the better. Yes, because because I want you to apply the Lean Six Sigma methodology not for the processes in the company you're working in right now. So no need to be an employee. We don't need a company, we don't need a boss, we don't need a machines, we don't need this big heavy resources to run the Lean Six Sigma projects. It's a total misunderstanding why Lean Six Sigma actually exists. The Lean Six Sigma is not to generate savings for the owners of the processes. The Lean Six Sigma is the best tool to become a better person, to improve the world around us, to help our customers and help other people, for example, employees. If we will help the customers and help employees, the owners of the industry, companies will benefit without any question. So we should change the focus, and this is why I want to show to everyone, with your help, that Lean Six Sigma can be applied at almost every problem. And the problems I would like to select for this project must have quite big impact to the most number of peoples all over the world. Okay, and we will show to everyone that Lean Six Sigma is really helpful. Lean Six Sigma can improve our life. Of course, it can be linked to some local teams, local people living, for example, in one country. But the more people we will attack with this is better. Yes? So you don't need to be an employee. You will pay nothing for this. You will pay only with your time, with your with your time, with your skills, with the time of the people you will invite. And you need to have a possibility to see me, to contact via internet, as I mentioned before. With the camera the best, because I would like to see your reaction. We'll also show your faces, therefore we need an agreement to use video in internet. I want to show everyone who is the leader of these great projects we will do together. Okay? So you don't need to be an employee. The project must be linked with the problem in the process that the most people face every day. So like collecting something, like sorting something, like reworking something, like processing something. One of the examples could be like wastes, yes, or garbage, or environment. Pollution. I think there are a lot of examples of these processes we are doing every day. And everyone is doing every day. Everyone is struggling. Everyone has a problem. Sometimes it's better, sometimes it's worse. So the aim for this project is that we will at the end create a best practices and we will share it all over the world. So we use Lean Six Sigma to understand what is the problem, we verify what is working or not, and at the end together we create a best practices that we will share all over the world. With the message, yes, Lean Six Sigma is for everything, and Lean Six Sigma has impact, and we are the people that we don't need any boss, any companies, any money to really change the world and show what are the root causes and what we can change. So I will announce this as well on other groups and other places. I'm quite active, so I will talked about this on LinkedIn, definitely on YouTube. I will reshare it to different groups in Facebook. So if you think it may be interested for your colleague or someone from your team or your friends, please share it to them. Say that I'm waiting for 5 individuals, 5 people. Doesn't matter where you live, what you do. If you have internet, if you have camera, if you have time, if you want to do something important, if you want to learn about Lean Six Sigma, this is the great project for you. It may take, I think it will take something like, moment. It may take about 3 months. Definitely, we will meet like twice a week, and the time is up to us. Time is up to us. I'm quite flexible, even if we'll need to talk like 2 o'clock during the night, my time, I will do so. So we will find the best time that everyone can join, and we will talk twice a week. I will pass to you all the knowledge. Hello, Satish. Oh, perhaps you will be interested in this. So if the stream will finish, please have a look at the beginning of the stream, because I'm offering an opportunity in great project. So it may take about 3 months, 4 months, I think, because this kind of projects will always consume much more time, because we will, I'm afraid, so we will have to collect some additional information about the process and the problem in the process. This is required by Lean Six Sigma, and this is why I think it will take much more time than normal project. Okay, but I think it will be great project, great adventure, and the chance to show that we have an impact. So please think about it. I will wait. You know how to contact me. If you would like to contact me on email, please write to this email: ilegowski.promaco.pl. So write to me on this email, anyone who is interested in this project. I think it's a great opportunity. I'm wondering what do you think about this, and I will just wait for your reaction. Great. So shall we start with measure phase? If you don't have any questions, I will just continue with the with the DMAIC project. And what we actually have to do is, I'm just looking here, okay. What we have to do is to give some introduction to define phase. And introduction to define phase is as follow, because we have measure phase, and in the measure phase there are like 3 main elements that we have to always remember about the measure phase. One is there are a few questions. Do I trust data I collect and use? So this is the first question. Do I trust data I collect and use? This would be quite good. You will use during the Lean Six Sigma project many results of your statistical analysis. You will show to the sponsor, to the customer, to anyone who will be involved in taking a decision, go or not go. You will show the results of your analysis, and it will be in most of the cases, some graphs, some analyze, some calculations. And you have to be prepared to defend, to guard, to enforce your suggestions exactly by this, with the answer to this question. So if you will spend enough time in the measure phase to verify if the data you are using are okay, the stronger will be your message, and no one will be able to, you know, kill it. And also it works opposite. If you are an expert in Lean Six Sigma, if anyone is showing you some graphs, some results, you may easily ask few simple questions, and you will know, should I trust this graph? Should I trust this guy or not? And this is what we will learn in the measure phase. So this is the first question we have to find an answer for. Do I trust data I collect and I use? Okay. So one, how the problem looks from data perspective. Sorry, it should be the same size as above because it's the same. Sometimes this PowerPoint is really frustrating. How is it possible? S, because this is stream, so everything is live. Also my mistakes are live. I'm not, you know, perfect guy. I made mistakes like everyone. There is no shame in making mistakes. What do you think? Oh, it's shame. It's a big shame. Igor Węgowski is teaching Lean Six Sigma and he's making mistakes. Aha. Are you going to trust me less if I'm making a mistake or not? Okay. So this is one. This is second. How the problem looks like from data perspective. So what we will do here, we will just use this this data that we verify. No, we will use the verified measurement system from the first question, and we will use it to collect accurate data, and we will try to see in the numbers what is the real picture of the problem and the process when we look at the data. So we will look for the differences. It's going up and down. What is the shape of this curve? What does it mean? How we can explain this? So we will look at the problem from the data perspective, and we will create at least few very important one but very easy graphs. And how the process looks like from Gemba. Do you remember, did I mention about Gemba previously? So Gemba is the Japanese word for the place where it happens. So exactly where the process is. So sorry, double S. Okay. See, I'm adding one S and the PowerPoint is thinking, no, you made some wrong mistake. Okay. So we have three main questions for the measure. Do I trust the data I collect and use? How the problem looks from the data perspective, and perhaps I should use here as well how the problems looks like from data perspective, and how the process, so the problem and the process looks like from Gemba. It means we have to go to Gemba and we have to measure the process, so we'll create a process map. So this is these are the most important questions in the measure phase. We go question by question. Every time we meet here, we will go through next question. So today, I hope I will be able to tell you a little bit about the data and the data measurement system, how we analyze this, what we have to remember, and how we verify the measurement system, and so on, so on. And one thing, what we will use in the measure phase, we will often repeat later on in analyze, because the measurements are happening all the time during the Lean Six Sigma projects. We are measuring all the time, and we are rely on data and measures. I'm not sure, let me see, no, not this one, I will show it later, but in general we are always analyzing two group of data about our problem and about the root causes, and both elements of the analyze must be measured in the proper way. In one of these elements are not measured in the proper way, the whole analyze, and our assumptions and suggestions are not true, and everyone can cross it out. So let's start with the first question. Do I trust data? And before we talk about do I trust data or not, I have to explain to you why and how we are collecting the data in the Lean Six Sigma. So let's have a look. I'm already writing a name of the graph that we will use, but how can I add here? Okay, doesn't matter. So let's assume that we are working at the quality control department, and our colleague is actually currently cutting the small shafts manually because the machine is broken. So he's cutting from the long big wires some shafts like this diameter, yes, some length, and we are taking every shaft he just cut and we measure it, yes, because we are working in quality department. So let's assume that the nominal value of the length is, for example, like 20 centimeters. So what we can observe that, okay, we will have definitely some shafts will have 20 centimeters, but they may be also shafts they have 21 or 22. So or perhaps let's make it more realistic, so 20.1 and 20.2. Okay, so it may happen that our colleague who is cutting will have this results as well as this results. So let's make it look equal. So you see, this is our nominal value, and here we have there is a chance. Moment. Why this great it should be dot or comma. No, it's 20, 0, 20.1, 20.2, 20.3, and so on. And please apply the sequence later on. You know, I was really trying to do this in a Google spreadsheet, but now I'm totally lost. I don't understand what this spreadsheet is doing. Sorry, perhaps it's a matter of dots, not commas. Okay. So we are here. We managed to force this Google spreadsheet working. So you see, we can observe during when we measure this different shafts that are cut, we can observe different lengths. Yes. So whenever our colleague who is cutting the shafts generate an effect in general, we are measuring it, and we mark every shaft on the separate row. For example, if he managed to let's assume we took the shaft and it was exactly between 20 and 20, below 2001 and 20. Yes, so next time he was cutting a second shaft, again it was, so we have already two shafts with this length, and suddenly we got a shaft that is a little bit longer, and in actual measurement is 2.02, 20.2. So every shaft my colleague is cutting and I'm measuring, I mark on this graph. So it was also this. Moment. Why it's always so I will just simulate here some measurements. Why I have to, why I can't here okay, it looks better now. So I'm simulating right now some process, yes, because every time I take the shaft, I measure it and I mark what is the real length I got for measurements. So second shaft, every shaft I'm measuring, and after a lot of measures, like it's 1 hour gone, 2 hours gone, 3 hours gone. So, and he's cutting, and we are measuring. Okay. So, and he has finished the job. He's going home. He finished measuring. And what we can see here, in general, we see the history of certain process. This process, perhaps let me do some more products. Actually, it should not be like this. Okay, so this is the history of certain process, cutting of wire, and what we have on the XY, on the x-axis, we have a potential measures. So what are the potential length of the shaft? And from this graph we can already conclude a lot of I mean, we can find some important information. For example, during the time we are measuring, very important, histogram is showing the very specific moment of history. Every time you are showing the histogram, you have to give an additional information from when to when the measurement took place. Not actually the measurement, the process. So it must be very precisely specified from what period of time this is the, from what period of time we see the measurements. So then if we know it was, for example, half a day last Friday from 10 o'clock to 3 o'clock, we can say that in this particular period of time we have never observed the length or the shafts shorter than 19.4, and we have never observed shafts with the higher length than 2.6, because this is the minimum and this is the maximum. Okay, the most number of observations was at the length 20. Okay, we were expecting this because 20 is our norm, what you would like to achieve. Our customers was asking for 20. So this is why this kind of graph is called a histogram, because it's showing the history. And very often the histogram, the height of the piles, and the histogram is drawn as the curve that is connecting the peak of these piles, and then we see some curve. It's also a histogram, so it doesn't matter if it's a curve or piles, whatever. So here we have the potential numbers on the x-axis, and can you tell me what we have on the y-axis here? What we are measuring here? Here we're measuring a quantities, yes? So you can see that, for example, here we have 1, 2, 3. So so here we have 8. So during all the production, we see on the histogram the most often measure was 20, and it was exactly 8 times. So 8 shafts, and that time was produced with the length exactly 20, or between 19.9 and 20.1. So it was, let's assume 20. For now, it's enough. And before we continue, I just want you to understand and look at this histogram, and please tell me, let's assume the number of shafts was 50. Let's assume, okay? So the highest peak is 8. So we have here an 8. And so the y is equal 8. Please tell me what is the sense, what is the meaning of having this kind of calculations, like 8 divided by 50, and we all calculate in percentage. So the 16%, what does it mean? What we can, how we understand this? What does it mean, 16%? Okay, so in total we cut 50 shafts. Out of this 58, only 8 has the length of 20. So we calculate the share of this top pile share among all the other shafts we cut, and it's 16%. What is the meaning of that? What do you think? This is also a probability. It means that if the same person under the same conditions, with the same tool, with the same raw materials, with the same environment, is going to cut another shaft, with 16% probability it will be exactly 20. Do you understand? That makes sense? So this is also probability. Therefore, we also call a histogram a probability plot, because it's telling us what numbers, if we are going to proceed further with the process, unchanged process, what is the probability that we will receive certain value. And now there's a question to us. Is it okay or not? Do we like this kind of probability or not? If we like, we leave this. If we like the process like that, if the probability of 16% to achieve 20 is okay, it means that we don't need to do nothing. I mean, it's okay. This is very often I'm asking, okay, what do you think? Is it a good process or bad? And we cannot say straight away, is it good or bad? We need some additional information to make this evaluation. We need a customer expectations. So we need to know what the customer is expecting, because if the customer is expecting, like, for example, from 19 to 21, it means the customer is looking at the numbers between, so the 20 plus minus 1 is the great process. Everything is in the scope, in the tolerance. There is no rejects, no scraps, everything, the customer is buying everything. But if the customer, for example, is looking 20 plus minus 0.2, the situation is slightly, totally different. We have a lot of rejects, so everything what is below the value of the customer is definitely a scrap. Yes. So everything what is below is the scrap, everything what is above is the scrap. So now we should worry. You know, the red elements, the red shafts which are too short, they may not be used for another product, we have to throw it away. The longer shafts, probably there's a chance to work out a little bit, rework a little bit and make them short enough to use into the product. So anyway, all we have to lose, scrap and throw away, all we have to rework is additional cost. From the Lean Six Sigma perspective, it's a waste. So in general, every process at the beginning and the problem has to be described also from that perspective. And actually we were doing this because can you tell me from using the definitions we learned last week for the Lean Six Sigma, how we can call this yellow area here? What do you think? How we can call this yellow area? And please use the definition we learned last week in the define phase. This is nothing more than CTQ, because CTQ is saying that I need you to measure this, the goal is this, and the tolerance I will accept is this. So exactly. So here we are measuring the length, this is a nominal value, and this is the tolerance I'm going to pay for. Everything below and above is a scrap. I'm not interested, I will not pay for this, and forget. So this is the CTQ, and CTQ we are using to analyze the quality in Lean Six Sigma projects. And actually the idea and the goal for every project in Lean Six Sigma is to eliminate the potential root causes that are actually caused this information. I'm sorry, really. I don't know why it's happening like that, but it was difficult. So the drawings. Can I put some drawings here? What is this? No. This is strange, really. I'm used to work with the Excel, and this is so difficult to work in this Google spreadsheet, really. Anyway, so there, here we have some, okay, why our measurements have such a big deviation from 20. The 20 is the nominal value, and sometimes we are observing a shorter measurements or longer measurements, yes, or below or above. So every time we are measuring something which is not exactly our nominal value, it means that something has happened in this particular moment when my friend was cutting. I don't know, there was he moved hand, the tool became not stable, or the table was moving, or the wind blows suddenly, or the temperature has changed. I mean, there may be a lot of different and several root causes, but there was definitely at least one root cause that forced him to deviate from the nominal value. So it was too small or too high. So every time we see some observation, some measurement, which is not exactly according to the expected nominal value, it means there was a root cause of these observations. And in Lean Six Sigma, what you have to do, we have to just identify what was the root cause here, what was the root cause here, or what was the root cause here, here, or here. And by identifying them, we can attack them, we should eliminate them, and in the results, we should get rid of these measurements below and above tolerance from the customer. And actually, if you would like to phrase ultimate goal for all Lean Six Sigma project, it means we have to just make a histogram smoother. So we have to eliminate the root causes. We should not observe something below and above tolerance, and the tolerance is smoother, it's smaller, and let's assume that it may look like so. Let's copy this. So this is like the current situation. So 20. Let's do like this. And how this may look like after the Six Sigma project. I will draw not perfect one. I will not draw a fully successful. You remember we discussed yesterday that the problem is slightly different case and subject than the project goal. The problem here are all the red elements. This is the problem. And very often the project will be how much I can eliminate this, and this may look like after the project. So we managed to move certain red measurements into the tolerance. So so before was like that, and then we just moved this red into the tolerance, and we have shape like that. So this is actually what Lean Six Sigma is doing. Yes, we are measuring this, and then we are applying certain techniques to identify the root causes. We eliminate the root causes, and then instead of this red measurements below and above, we have more in scope, more in tolerance. You please understand, more in tolerance for the financial elements. So for the finance of the company, it means more sales and more profit, more income. Yes, better financial results. It's simple. Okay, I think you understand. So this is actually the goal of the Lean Six Sigma. And why I'm saying this, because we have to now, with this first no, this one, with this first question, do we trust data I collect and use before we will make any graph, any suggestion, any analyze? We have to be sure if we trust the data. Should I really use this data, and if the data really looks like this? Because we can make a mistake by taking the wrong data and make the wrong analysis. So so this is the histogram. We know already, whenever I will draw this kind of a graph, you have to and I will ask, what is this? You cannot say, oh, this is a perfect process or good process or whatever. No. You have to say, this is some kind of history of the process. It's too early to identify, it's too early to judge, it's too early to comment. We have to understand the process, we have to observe the process, we have to learn the process to really interpret the histogram correctly. Yes? Okay, later on you will be more familiar with this process. You will be able to give some comments from the first glance when you see the histogram, but it will come in time. Don't worry. So here we have the histogram, and now what is the problem? What is the problem with the measurement system? Why we have to talk about measurement systems so heavily? So let's assume, so I will change the colors right now. I'm not interested in this different colors. Now I will just make it this color. Let's assume we have a blue one, blue one, blue one, blue. No, actually, so moment, I will just make a one example, and then we can. Okay, I'm not saying it's perfect. By the way, no one is able to draw a normal curve with when he's drawing by hand. Okay, so let's do like this. So let's copy this a few times, and I will show something to you. Pach and pach. Okay. So let's assume now I will draw a process. So the process looks like this. So it means the process is quite narrow. You see, I'm reducing the variation. I'm eliminating the effects of these root causes, okay? So let's assume the process looks like this. The real process, I mean, the process that is generated by the machines, by the process of transferring some energy and raw materials to some product. So this is the real result of the process of cutting, making a shape on some chemical processes. And every effect of the process has some characteristics like weight, hardness, some dimensions, some volume, some density, and so on, some color and smell, everything. And unfortunately, we as a human, we are a very weak measurement system. We cannot measure it with our own sense. How we can measure? Oh, okay, I mean it's okay, it's quite stiff, yes, but what is the real hardness? What is the dimension? I think it may have like 5 or 6 millimeters, but this is exactly accurate. I don't know. This orange is exactly this number in real standard. So we are not able to measure effect of the process with our own senses. We are too weak, and very often when we are measuring a process, so the process is generating. Let's assume this is the dimension, or how the dimension. Yeah, this dimension. Yes, okay. There's a cup, and what is this dimension? The height of this cup, or diameter of this cup. Yes, and we are measuring many pens, and we are observing like this. Wow, it looks like, no, we are measuring this and putting on the paper, and we showing the results like that. And someone, he knows exactly what is the real outcome, and saying, no, it's not true. The process looks like this. It's much more better. And you're saying, no. I have measured this, and I do the measurements, and they look like this. It's much more worse. So why process? Let's call it. Why the process may be different from our observations. So the process, and here are the measurements. Because unfortunately, what's happening, by applying a measurement system, we unfortunately add something to what process is generating. Perhaps it doesn't look like this, so don't worry. Oh shit! Sorry, I didn't mean so. So lucky the measurement system. So the histogram of measurement system is not so bad. It's always a little bit better than our system, but at least it has some deviation. So what's happening actually? The process is generating some results by applying different tools, measurement procedures, measurement techniques. We are doing this in the strange environment. To the process, we are adding a measurement system variation, and we have our measures, final measures, and we are taking conclusions out of these final measures. So what we have to do, is there any chance, what you have to do to have the measurement results very similar to the process? What do you think? What is our goal? We have to just make the histogram of the measurement system as the single line. The perfect histogram of the measurement system should look like this. It must be a straight line. It means that the measurement system, from its nature, is not adding anything. Blah blah blah. How can I reduce the size of this? I'm not saying it's a good idea. Okay, anyway, so there's a process, measurement system, and if the measurement system is exactly like this, one straight line is not adding any plus, any minus to what we measure, and the measurement system is equal to the process. So this is what is the general the aim of the question in our presentation. So what do I trust data I collect and use? We have to make sure that the histogram of the measurement system is a one straight line. And yeah, and I think this will be the subject of our next session. So I don't want to spend too much time right now with you. It was already a lot of information. I know you have to think about it. I know it's not so easy to to understand and capture everything. If you have some questions, if you have some doubts, please write some comments or in YouTube or on Facebook. I'm here to answer all these questions. I want you to really understand what is behind the measurement system and why we have to focus so heavily on the good measurement system, because if we collect wrong data, our conclusions and our quality of our work in Lean Six Sigma projects will be also bad, not like it should be. It's not reflecting the reality. So this is why the measurement system is very important. And at the end, I would like just to remind you that I'm gathering a team of 5 brave, ready to hard work people. We would like to attack one of the process with the problem that the most people face every day. We will apply a Lean Six Sigma methodology to these problems and these processes. We will work hard for like 3-4 months. I will give you all the knowledge. I will pass to you everything what is needed to fulfill the task. We will use Lean Six Sigma. We will do it online, so I need you to be able to connect to the internet and switch on your camera. I would like to see you. Each of you will do the separate project. We will talk about what is the subject. Perhaps we will ask even the audience, in the society, in Facebook or around you. So first we have to meet on Skype or Zoom or in internet. I will explain everything to you. We'll discuss, and you will have a chance to learn a very good techniques to solve the problems. We will be able to give some suggestions to everyone, because the main result of every Lean Six Sigma project is that we are suggesting, we are changing the way we did things before, and it was wrong. So we will look for the root causes, we will find the best solutions for that, and we will create new standards. And at the end of this project, we will share the standards to everyone. So we will have a chance to impact some. It doesn't have to be very specific, very complex process. It may be very simple process. I think that the simpler process, the better. And then we will share these results with the others, and this will be our impact. So Lean Six Sigma and we definitely have an impact to how we live, what we do to eliminate the problems in the most common processes around us. So if you would like to take this challenge and be part of this project, I'm waiting for 5 participants. Please write an email with the answer why you would like to participate. If you have already an idea for the process and the problem within the process that you would like to analyze with the Lean Six Sigma approach, please write it as well and send to me. I will share your suggestions and your emails with the others. We discuss the ideas and then we start work. Simple like that. So thank you very much. I am looking forward for your comments, what opinion about the project, and of course the measure phase. And see you tomorrow. We'll continue the measurement system analyze. Have a good evening.